So again, the values of a that are other than 1 will either cause a stretch if the a value is greater than 1. It will cause a shrink if the a value is a fraction less than 1. And if you have a negative, it's going to cause the reflection. Now, in all of these functions, I've chosen to use the values -1, 0, and 1. And basically, all that we're doing on these problems is taking our original function, our parent function, and multiplying every y value by 3. So if you go back to the original function, when x was -1, we had a 1/2. Well, what's 1/2 times 3?
1/2 times
3 halves, right?
Yeah.
And then my original function had, for x value of 0, it had a 1. Well, what's 1 times 3? 3. My original function had an x value of 1 and a y value of 2, and 2 times 3 is 6. All right? So, let's go ahead and fill in the chart for B and C as well. When I had -1, again I had 1/2. Well, 1/2 times -1 is -1/2. And then when I had a 0, the y value was 1. 1 times -1 is -1. When I had x equals 1, my y value was 2, and 2 times -1 is -2. So that's where these values are coming from. Look, I'm just taking whatever the a value is and multiplying it by my parent graphs, my parent functions table, basically. Did the same thing over here with a half. Now, if you think of it just by plugging in the x value, 2 to the -1 is 1/2, and 1/2 times 1/2 is 1/4. 2 to the 0 is 1. 1 times 1/2, 1/2. 2 to the x, when x is 1, is 2. 2 times 1/2 is 1. So we've got our chart filled in. Now, anytime that you've got an a value other than 1, I'm going to require you to make a table. You're not just going to use the simple shift point transformation, because it's not quite as simple as when the a value is equal to 1. Now, when we graph these things, look what happens. In the first one, our asymptote is the x-axis because we didn't go up or down. We're going to graph -1 up 3.5. We're going to go 0, 3, and we're going to go 1, 6. Now, I want you to notice something that's pretty interesting. When my parent function was graphed, I had a y-intercept of 1. But here I'm multiplying my parent by 3, and look where my y-intercept is. How many units up is that?
3.
3 units up. So my parent had an a value of 1 and a y-intercept of 1. This function has an a value of 3 and a y-intercept of 3. So do you see a connection there maybe? That the y-intercept is determined or affected by the a value? Now look over here at this one. Notice that this graph is facing down because it's a reflection. I graphed the point left 1, down 1/2, 0, -1, and 1, -2, and it shifts and it makes this thing reflect. So that all of the graph is below the x-axis. So all the y values are negative for all x values. I want you to notice that my y-intercept is -1. What is my a value? What's the a value? Look at my pins pointed.
12.
-1.
That looks like a 12.
It's next to the 2. Okay? My a value is -1, and my y-intercept is also -1. Interesting connection. Now look over here at this last one. In this last one, we're shrinking by 1/2, so this thing is going to be a little bit wider than the original. Notice that my y-intercept is 1/2. What is the a value? 1/2. Interesting. It appears that my shift point is being determined by whatever the A value is. So if my A was 7, where would my y-intercept be? At 7, up 7. So in that case, I can kind of have an idea when I graph it that I can graph it a little bit more quickly maybe than otherwise. But here's the thing. Whenever that A value is there, and it's other than 1, it's going to make it a little bit, there are more things to remember. So we're going to make a table anytime the A value is other than 1. Okay, let's go over to the right side of the page. It says compare each of the following to its parent graph. How is it different? Now notice in A, we've got a 5 in front of the 2 to the x. So what does that mean? Stretch by 5.
Why are they marked out?
Okay, they're marked out because they are linear. Since I wanted this graph, this worksheet rather, to deal with only exponential, even though this worksheet was a comparison between exponential and linear, which is good. We've kind of done that. But I just marked out the linear ones. Alright, you can see in part C that we have a reflection and a stretch by 3. So I'm going to ask you on the quiz to tell me what the transformations are in words. When I say describe, that's what I'm talking about. Put the phones up, guys. So we're going to reflect and we're going to stretch by 3. Alright, now what can we conclude about, I'm sorry, I didn't do E. E is obviously a stretch by 4. Okay, now you could also say more narrow by 4. Or you could say steeper by 4. Do they all mean the same thing, Devin?
Yes.
Absolutely. Alright, now what can you conclude about the following function? When I have a number in front other than 1, I'm either stretching or shrinking. So write that down, stretch or shrink. Alright, now, in number 1 of classwork, says name the slope of the graph, shape of the graph, of the function, and describe how each function has been transformed from the parent function. Alright, shape is referring to either growth or decay. Now, all of these are growth. All of the exponential functions here are growth, because they all have a base of 2, which is greater than 1.
If it was a negative 1, it would be, what's it called, right?
If it was negative 1, it would be reflection. All right. If the base was 1/2 or any other fraction less than 1, then it would be decay.
Yes, sir.
All right. So in part G here, all right, we're going to go left 2 because x plus 2 tells us to go left 2. All right, in part B, we have a linear function, so we mark that out. Part D is also linear. You can mark it out. All right, part C, notice we have an A value of 1/2, so we're going to shrink or be wider by 1/2, and we're going to go to the right 4 because of the -4. You need to pay attention to this so you understand what the quiz is going to be asking tomorrow. Okay, part E, since there's an x plus 1, you know that there's going to be a left 1. There's a -4, so there's going to be a down 4. So fill that in. In part F, there's going to be a stretch by 3. It's going to be right 6 and down 1. In number 2, we're going to write an equation for the exponential function that has been shifted up 1 and more narrow. Now, look at the one that I did here. It says y equals 3 times 2 to the x plus 1. Could I use a different value than 3 for this? Could I use another value?
Yes, sir.
Yes.
It does.
What type of value must I use if it's more narrow? Greater than 1. Absolutely. It's got to be a value greater than 1. Is 3 greater than 1?
Yes, sir.
Yes. So 3 times 2 to the x plus 1. So you could have used a 5. You could have used a 1.5. As long as it's greater than 1. All right, the next one. Reflected and wider. So if it's reflected, I need a negative. If it's wider, I need a fraction less than 1. So what's a fraction less than 1? How about 1/2? And then times 2 to the x. That's all I need. So make sure when you're writing the function or the equation that you write y equals, or you could say f of x equals, and then you're going to have a base of 2 if it's growth. All right? If it's decay, you would have maybe a base of 1/2 for the parent. And then whatever the transformations are, you put those in the proper place. All right, part C, shifted left 2 and more narrow. So, more narrow would mean a number greater than 1, such as 3. Left 2 would be x plus 2. So y equals 3 times 2 to the x plus 2. Now, this last portion is not going to be on the quiz. I am not going to ask you to write the equation from the graph, but I went ahead and did it here.
Oh, man, that was the only thing I was good at.
All right? Even though it is still important to have an idea. Now, especially when it comes to matching a function with a graph. All right? Because we know how we are going to be asked to match the function. I'm just not going to ask you to write out the function because it can be a little tricky. Now, if I ever did ask you to write out the function, I would only do it after I told you that the a value is 1 and the base is 2. Then you could easily do it. Now, look at number 3a. This is a right here. All right. Notice that my asymptote is up 1. So that tells me I'm going to have a plus 1. Also notice that the shift point, which is 1 unit above the asymptote, has gone to the right 3 units. That tells me to use x minus 3. So that's where these values came from. In the second one, part B, notice that it's a little different this time. Okay? My base is actually a 3. And the reason my base is a 3 is because I had to go up to, I'm sorry, when I plugged in, let's see here. When I plugged in 0, I got negative 1. The only way to do that is if I have a base of 3. I think I talked about this yesterday, so I'm not going to talk about it anymore. All right, this last one is a decay function. Why is it decay? Because notice it's going down to the right. It is the exact basic, I'm going to say opposite of the growth parent. So our base is 1/2, and I'm going to go to the right 2, so x minus 2. I would only ask you to write the function from the graph if I tell you that the a value is 1 and the base is 2. All right, now that concludes our worksheet. The quiz, again, is going to look just like this worksheet. Now we're going to watch a short video now that you can find on YouTube if you would like to do that.